I've seen students that are taking Chapter 5 of this Precalculus book. It's a pretty heavy-duty book right over here, and we will be looking at Chapter 5, one of the questions there, for the chapter review finals. So the problem is on page 401, Chapter 5, the Chapter 5 review. To give you the information that the sine of u is negative 5 over 7, and mu is between pi and 3 pi over 2. That's the given information. Since pi is 180 degrees right over here, and u right over 2 is 270 degrees, u is in the third quadrant. So that's the first step we have to do, to draw it out first. Here's the origin, and it radiates out towards the third quadrant. And here's the angle u, making 90 degrees. Since this angle sine is opposite over hypotenuse, -5 and 7, you have to use the Pythagorean theorem. Let's call this x right there. X squared plus -5 squared is equal to 7 squared. X squared plus 25 is equal to 49. X squared is equal to 24. X equals the square root of 24. Simplifying that radical, it becomes 2 radical 6. And so this value is going to be 2 radical 6. This is just for u price. Don't forget there's a negative factor there. Now, since we have that, we have to find the double angle for the sine. Sine of 2u is equal to 2 times sine of the angle times the cosine of that angle. That becomes 2 times the sine of that angle right there. This is -5 over 7, opposite over hypotenuse, times the cosine of that angle is adjacent to hypotenuse. -2 radical 6 over 7. So multiply those two out, you get a negative, and negative is positive. 7 times 7 is 49. 2 times 5 is 10. Times 2 is 20. 20 radical 6 over 49. Whoop, there it is right there. Let's go down to see what it is. Cosine of 2u is equal to cosine squared of u minus sine squared of u. So, cosine squared of u, cosine of u, is going to be -2, 6, 7. We're going to square that minus sine squared. -5 over 7, 20 squared. So sine of u, which is -5 over 7, and we're going to square that. That's what this means. Working that out, -2 radical 6 times -2 radical 6 is going to be 4 times 6 is 24 over 49, minus -5 squared is going to be 25 over 49. And that's going to be equal to -1 over 49. That looks like a really suspect number, so I'm going to try another formula right over here, see if it matches. I know that the cosine of 2u is also equal to 2 cosine squared of u minus 1, or 1 minus 2 sine squared of u. So let's try this one right over here. 2 times cosine squared of u. Cosine of u is going to be adjacent over hypotenuse. It's going to be -2 radical 6 over 7, 1 squared, minus 1. Let's work this out just a little bit further. It's going to be 2 times, that's 4 times 6. 2 radical 6 squared is going to be 2 radical 6 times 2 radical 6. And when you do 2 radical 6 times 2 radical 6, it's going to be 4 times root 6 times root 6 is 6, so 4 times 6 is 24. The negative cancels because negative square is positive, so it's going to be 24 over 49 minus 1, which is 49 over 49. 2 minus 49 is going to, 2 times 49 is going to be 48 over 49 minus 49 over 49, which is negative 1 over 49. Oh, it did match up. This is the first time I'm doing this problem, so I'm not quite sure if the numbers were correct on this one. Okay, so let's try the third problem right over here. Given this information right over here, I'm going to try to figure out what the tangent of 2u is. And the tangent to u is going to be 2 tangent of u over 1 minus tangent squared of u. I could have used this formula right over here, or another way I could have done was I could have used sine of 2u over the cosine of 2u. If I use this formula, I would get the same answers as this formula right over here. So I'd rather use this one because of the fact that I already have the sine and the cosine. So that becomes the sine of 2u is located right over here. 26 over 49 divided by cosine, which is negative 1 over 49. I put the negative in front. To do that, I multiply by the reciprocal, which is 49 over 1. These cancel, and it was negative 20 radical 6. Hopefully, that's the answer in the back of the book. I'm not quite sure, but I hope so anyways. Good luck on your test, everyone.